Mr. C is making YouTube videos, and today is about properties. Hey guys, how are you? Today we're going to learn about some properties. So, the first property I want to talk to you about is the commutative property. And what the commutative property does is it talks about the order of addition and multiplication expressions can be flipped or rearranged to still get the same answer. So we model that by saying a plus b is the same as b plus a. If we fill that in with real numbers, that'd be like saying 3 plus 5 is the same as 5 plus 3. Either way, we're still going to get 8. Doesn't matter what the order is. In multiplication, it's the same thing. If we do 8 times 4, that's the same as 4 times 8. Both of those answers are going to give us 32. Doesn't matter the order. Okay. The next property is the associative property. The associative property is the grouping of numbers in addition and multiplication problems does not change the answer. So we just learned about grouping when we did our order of operations. And the really cool part about that is if it's all addition, only if it's all addition, we can change the brackets. It's not going to change our answer. The order at that point won't matter because it's all addition. So I could do b plus c, then plus a, but that would be the same as doing a plus b first, then c. Watch what I mean. If I do 3 plus 4 plus 5 inside of the brackets or inside of the parentheses, it'd be the same as doing 3 plus 4 in the parentheses and then plus 5 at the end. Well, Mr. C, that doesn't make any sense. Well, sure it does. 4 plus 5 is 9 on this side. We do that first, then plus 3. That's going to give us 12. Well, on this side, I would do 3 plus 4 first. That would be 7 plus 5. And 7 plus 5 is also 12. It works the same way with multiplication. I could do something like 7 times 8 times 9. And for the same reason, when it's all multiplication, the order doesn't really matter. I could do 7 times 8, then times 9 at the end. It'll still give me the same number. And that's a really big number, so we don't need to work through that one. Okay. The next property is the identity property. And the identity property is pretty cool because it's a little different for addition and multiplication. They're kind of the same kind of rule, but they're just a little different because addition and multiplication are just a little bit different. So addition, when we take 0 and add it to a number, it does not change the value. Okay, so if we took a plus 0, it'd still equal a. If I put real numbers in here, 7 plus 0 still gives us 7. 7 is one of my favorite numbers. How about you? Don't we go to a school called 7? 7 something? 7 Lakes? 7 Lakes! Ah! Okay, here we go. Back to multiplication identity property. So if we do a times 1, we're still going to get a. So if I take something like 6 times 1, that still gives me 6. The identity of the first number is not changing. Okay, the last property I want to talk to you about today is the addition and multiplication inverse properties. Okay, the inverse property for addition talks about adding a number and its opposite will give us 0. So watch this. A plus negative a, they'll undo each other and we'll be left with nothing. So watch this. If I take 15 and I add negative 15, that's going to give me 0 because the 15s will undo each other. It's the same as saying 15 minus 15 to get 0. But when we think about it of adding the opposite of what we started with, we'll still end up getting 0. In multiplication, we call that multiplying a number by its reciprocal will give us 1. We talked about that earlier this year. So if I did something like this, 16 times its reciprocal, which means upside down version, well, upside down of 16 would be 1 over 16. Because remember, this first 16 over here is over imaginary 1. It's invisible math. But when I do that and I multiply across my numerator and denominator, let's just put that invisible math here so we can see. 16 over, or 16 times 1 rather, on the numerators would give me 16. And then across the bottom on the denominator would give me 1 times 16. And 16 over 16 equals 1, just like it's supposed to. All right, let's go on to the next page. Oops, shouldn't be there. On this page, let's determine whether the two expressions are equivalent. And if so, tell what properties we're using. And please, 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 do not do this one, number 9. Do not do number 9. So let's start with number 1. So I look at this and I think, are these equivalent? Well, I could do the math on them. I'd see, well, this one's going to be 6 times 7, which is 42. And this one's going to be 21 times 2, which would be 42. So yeah, they actually are both the same. They both equal the same amount. We just have to do it in a different order because of the groupings. So are they equivalent? Yeah, absolutely they are. But why? What properties are we using here? Well, I think we're actually using 2 here, aren't we? I think we're using the associative property, because remember, the associative property is talking about the groupings not matter. But I also think we're using the commutative, oops, there we go, the commutative property, because remember, the commutative properties talks about how the order of multiplication doesn't matter. I think we're actually using both of these here, wouldn't you agree? Let's take a look at the next one. The next one has 16 divided by 8 and 8 divided by 16. I don't think those are the same. If I even just write them in fraction form, 16 over 8 and 8 over 16, I notice that where they're using the same numbers, I suppose, they're in different positions. One's in the numerator and one's in the denominator. And the first one is a mixed number or an improper fraction, right? Improper fraction changes to a mixed number, which means it has a whole number out front. This one is just a normal fraction. I think that's equivalent to 1/2. So are these two expressions equivalent? I'm going to go with no. I'm going to go with a big no on that one. And it's because we cannot use commutative property on division. We cannot do that on the division. It only works for addition and multiplication. Division, no, no, no. Hey, I want you to try 3 through 8 on your own. And again, do not do number 9. And then I'll press pause on my video, and so will you, and we'll come back and we'll talk about the answers. All right, guys, let's take a look at our answers. So number 3, I think that it is not going to be equivalent. Okay, it's not inverse because it's not reciprocal. Okay, how about number 4, 16 plus 0 and 16? Yes, I think those are equivalent, and I think it's because of the identity property. Number 5, I do not think they're equivalent because we cannot use the associative property with subtraction. Number 6, is it equivalent? Yes, I think it is, because 14 and 14 times 1 are the same thing, and that's the identity property again. Number 7, for 7 lakes, ha ha ha. So we take 32 plus 4 and 4 plus 32. They both equal 36, and they are equivalent. And I think it's because of the commutative property. And then last but not least, number 8, it looks like it was trying to do what we were doing on number 1, except this time they're not going to be equivalent. because the associative property is not going to be able to be used on division. Okay, guys, there's 2 word problems below this, and I want to go through those with you. So I'm going to go back to my other page here. Okay, this one says, Mr. Watley, Ms. Lycos, and Mr. Seltzer plan to take their music class to a musical review. Tickets cost $6 each. They need a total of 48 tickets. Using properties, write 2 equivalent expressions that can be used to determine the total cost. So I think if they have 48 tickets that they need times $6 each, couldn't we do that in a different order? Couldn't we do $6 times 48 kids? I think we can. And I really think that that's because of the commutative property, right? That's the property that we would use. Because remember, commutative property, if I check back at my notes, it's flipping the order of multiplication. So that one would be because of the commutative property. Super cool. Next one. Students in Miss Rivas's class were participating, or sorry, they're practicing their multiplication skills. Maybe I should practice my reading skills. Let's start over. Students in Miss Rivas's class were practicing their multiplication skills by rolling 3 6-sided dice. Wapi rolled a 2, a 3, and a 5. He multiplied 3 numbers as follows using the order of operations. 2 times 3 times 5 equals 30. Right another way, Wapi could have performed the multiplication without changing the order of the numbers. So let's take a look. We could just do 2 times 3 in our parentheses, and we could do times 5 to get 30. That's the way it shows in the problem. Well, what is another way? Well, another way could just be take 2 times the quantity 3 times 5. Because think about it. We'll do 3 times 5 first, and we'll get 15 times 2. That's both going to equal 30. Just another way to show it. And guys, that one is the associative property, because we're just regrouping, and it still gives us the same answer for addition and multiplication. All right, friends. So for a class time today, whatever you have left and or for homework, I want you to take a look at the last page of this packet. It's very similar to what we were just working on. So take a look at those. I want you to work on it for a little while. If you're just doing this for homework at home from remote learning, just pick 3 of the ones up top and 3 of the ones from this bottom section to do for homework, okay? All right, guys, have a great rest of your day. Thanks for watching. Bye.